Welcome to lesson 12, Coastal Management. Please write the title and copy the keywords. So today we're going to be learning about how do we look after the coastline, how do we protect it, how do we stop it eroding, and that's all about coastal management. Please pause the video and write the answers to these questions. Here are your answers, please correct. So today we're going to try and build up a detailed profile of different ways of managing, looking after the coastline, trying to stop erosion. So from your definitions, you wrote down hard engineering and soft engineering. Now, look, hard engineering is essentially, it involves changing the landscape by building man-made structures and also trying to stop the sea doing what the sea does, which is to erode. So it's, environmentalists are not particularly keen on hard engineering because it's not natural, it's man-made. On the other hand, soft engineering often involves working with natural processes, not trying to stop them completely. So what I'd like you to do, please, is to either copy out this table, or if you have a printer, print it from the attachment. And then we're going to draw some sketches in a moment of these different types. So please neatly copy these diagrams into your book. Pause the video in a moment to do that. What I'd like you to do is we're going to go through one by one each of these coastal management techniques, and they are hard engineering, so they change the landscape. And what I'd like you to do is to annotate your diagrams with key facts and information. If you want to watch the two clips that talk about these, please do so, and they are in the description beneath this video. The first one we're going to talk about is a sea wall. Now, the sea wall is usually made from concrete. Okay, it won't be a local stone. Concrete is a man-made material. It's not a natural stone at all, not a natural rock. Okay, this means that it's very resistant to erosion. The important thing about the seawall is that the base of it is often curved. And what this means is that as the wave comes in, and usually it's to protect against destructive waves which will erode the coast, as the wave comes in, the swash of the wave crashes down onto the seawall, but the curved end of the seawall pushes the wave back out to sea. So it more or less stops erosion. Now, the important thing about the curved shape is that it deflects the energy of the sea or of the wave. Okay, it deflects. So those words I've put in there are important. It deflects the energy. The second thing we're going to talk about is a rip wrap. This one here. Now this is also called a rock armour. It's slightly different, but it's more or less the same thing. These are giant piles of stones. Giant piles of, sorry, I should have said piles of rocks. They are very, very large. They're huge. Some of them are as big as a car. The type of rock is usually a very resistant rock. So often they're going to be granite or something like that. The only thing is, though, that these aren't local materials because the local rock is eroding quickly, so it's probably going to be sedimentary. So these rocks have to be transported a long distance, and that can be quite expensive, just as the seawall is made from expensive materials too. I just would like to add to riprap that the important thing about riprap is that it absorbs the energy of the wave and it breaks up the wave. So whereas the seawall deflects the energy of the wave, the riprap absorbs the energy of the wave. The next one is called gabions. Now these are essentially wire cages filled with giant rocks, large, tough, resistant rocks. Again, what these do, if you place them in a line in front of the cliffs, what they do is they absorb the energy of the wave, just like the riprap. The only problem, or one of the problems with gabions, is that they're in wire cages. So the wire can tend to rust over time and they can look quite unattractive, and that might affect tourism and so on. The last type I'd like to talk about is a groyne. Now a groyne is either, there's two types. There are either wooden fences or there will be a rock groyne. Now these stick out into sea. These stick out into the sea like this. Okay? And what they do is they trap sand transported by long shore drift. So if the waves are coming in at an angle like this, what they do is they block all that sand from being transported down the beach or down the coast. And what this does over time is it builds up the beach. It builds up the beach over time. So what happens is the waves break much further out, and they break earlier and much further out. And this means that the cliffs here are protected from erosion. So I'll just say one more time. Groynes can either be a wooden fence or they can be a line of rocks. They stick out to sea at right angles to the coast, and what they do is they trap sediment, sand, transported by long shore drift. The beach gets bigger, and that causes the waves to break earlier and further out, protecting the cliffs at the back. Now, another good thing about groynes is that because they build up the beach, that can help tourism, and then the money generated in the economy can help pay for these coastal defences. So please make sure you've got those annotations on your diagrams. So now we're going to look at soft engineering. Please pause the video and copy this diagram as well. Once you've done that, you can watch the second clip in the description below the video. So the two types of soft engineering we're going to look at are beach nourishment and managed retreat. Now, beach nourishment is really straightforward. It essentially involves dumping lots of sand onto the beach and building it up over time, making it taller and deeper and wider. And so what this means is that waves break earlier and they break further out, therefore protecting the cliffs at the back of the beach. The only problem with this is, well, there's two problems. One is that it's quite fairly expensive. The second problem is that after a big storm, often in winter, parts of the beach can be completely washed away. So you have to keep redoing it over time. You have to keep nourishing the beach with more sand over time. The second type is called managed retreat, and as you can see, this part of the coast that I'm highlighting here has just been allowed to erode naturally. So, you know, is managed retreat even a strategy? Not really, because it involves essentially doing nothing. But they make a decision about which part of the coast to protect and which part of the coast they let erode naturally. Now, because there are houses here, because this area is probably of greater economic value, they've decided to protect it. Whereas this place, this part of the coastline along here, doesn't have houses, might just have farmland, which is not as economically valuable. So managed retreat is good because it works with natural processes and it allows resources to be spent in a more targeted way where they're needed. Another good thing about beach nourishment down here, I should have said, is that by building up the beach, you promote tourism and therefore more resources can be spent on coastal management. Please make sure you've copied those diagrams. This is your sheet from earlier that you either printed or you copied down. So what I'd like you to do now, using my explanation and your annotated diagrams, I would like you to fill this sheet out using your own ideas as well. And I'll show you the answers in a minute. Okay, so here are the answers. Please green pen anything that you forgot or you didn't get and ensure that's completed. Study this cartoon for a few seconds and ask yourself, what is it trying to say? We now have two 3-mark explain questions, which means we're going to be making a point, we're going to be developing it, and we're going to be developing it again. And the same here. Now, what is interesting about these questions is that the first one asks you to explain how a particular type works. The second one asks you to choose your own type of hard engineering, for which the first point, the first mark, will be simply naming it. So yeah, you could use groyne for the second question, but challenge yourself and try and use something else, seawall or riprap or so on. Pause the video, give it a go. So here's the answers. So what we needed to say what a groyne was. It's a wooden fence or a line of stones. Point. Which, this word which is in there, which is excellent. That allows us to start making a chain of reasoning. Which traps sand, transported, we've got the name of a process, by longshore drift. But how does it, let's go back to the question, how does it reduce coastal erosion? This was the last bit. This builds up the beach, you could have said, or you could have said the waves break earlier, further out, so erosion is reduced. Mark it, green pen, what you didn't get right. The second question, explain one way in which hard engineering can reduce coastal erosion. I chose seawall, but you could have said riprap. Remember, the seawall deflects a wave, the energy of the wave back out to sea, whereas the riprap absorbs and breaks up the wave energy. So there's your development. For the double development, all you needed to say is wave energy erosion, hydraulic action is reduced. Any one of those would have been absolutely fine, or something similar. Give yourself a mark out of 6. Challenge yourself now. Using the figure, meaning this photo here, explain both an advantage and disadvantage of the management strategy shown. So what is happening in this picture? Then what you need to do is a point develop for an advantage and a point develop for a disadvantage. Pause the video now, give it a go. Okay, so the answer. What you could say is one advantage is it works with natural processes. You could have said because it then builds up the beach. You could have then said it reduces erosion. So that could have been your point, and that could have been your development, or that could have been the original point, and this could have been the development. The disadvantage was that it has to be redone frequently. Point. Because there are big storms which erode the beach. So just develop that idea. Why is it that it has to be done frequently? You know what is interesting about this is it doesn't ask you to name the strategy, even though you could do, because the question is asking you about an advantage and a disadvantage, not asking you about explaining how it works, even though that is included. Okay, so the strategy, of course, was beach nourishment, where you're pumping sand onto the beach. So to finish off this lesson, I'm going to give you 7 photos, and I would like you please to name the management strategy you can see. 10 seconds starts now. Okay, time is up. This first one was a wooden groyne. Notice on this picture how much the beach has been built up here, and what's happening is the waves are breaking there instead of all the way up here. Next one, number 2. 10 seconds starts in 3, 2, 1, go. Okay, so the answer is easy. That was your sea wall. So notice how the bottom of the sea wall is curved. Now what happens is that as a large destructive wave breaks, the swash, the energy is deflected back out to sea. Number 3, 10 seconds starts now. And the answer was there's a rock groyne. Now, interestingly, you can actually see down here that there's also a riprap at the back of the beach. But this here is our rock groyne. We're going to learn about this area next lesson. What happens is the prevailing wind pushes the waves in at an angle, like this, and longshore drift, that zigzag motion, where sediment is transported along the beach, pushes sand downwards that way. So if you stick a rock groyne in there, it builds up the beach, as you can see here, and protects the land all the way along the back of the beach. Problem we've got though with groynes is after that final groyne in a line, after that last groyne, so this is the last one in a line of groynes, look what's happened here. Erosion has actually increased. And that's the problem with groynes, is once you get to the last one in a series, suddenly this part of the beach doesn't get the sand that is supposed to be coming down. So what happens is erosion increases, and that's something we're going to look at next lesson. Number 4, 10 seconds, go. The answer was beach nourishment. You can see actually at the back of this beach here how by nourishing the beach and keeping the level of sand topped up, plants have established at the back of the beach, and what you end up with is a formation of sand dunes. Number 5, 10 seconds, go. And the answer was, of course, riprap rock armour, which absorb the energy of the wave. Number 6, 3, 2, 1, go. Okay, the answer here was managed retreat. This whole area has been allowed to erode naturally. Now, you might look for clues. Why is this been allowed to erode naturally? Well, further up the coast, it looks like we've got some houses. Here, we just seem to have a kind of caravan site. Maybe the council decided it wasn't economically valuable enough for the area, so they've allowed it to erode naturally with no defences at all. And the last one, 10 seconds, go. Okay, and the answer was the gabions, the wire baskets filled with large stones. They're at the back of the beach here, and they've probably also got a sea wall along here. So this would only protect the coast when it's at really high tide. But as you can see, some of it has already started to rust, and you could argue that it doesn't look that aesthetically pleasing. Okay, so next lesson we're going to look at lesson 13, which is all about a case study called Holderness. I'll see you then. Thanks.